So we continue with reviewing the C++ code. Today we will cover the add unweighted bound function, and for that we have the signature like the following: return a boolean if everything is failing. So if true is returned, everything is fine. The first argument is the new bounds array. The second one is the skeleton we want to adapt. Then, as usual, we check if the skeleton is valid. If we have correct bound a valid new bounds array, that's how it could be defined properly. And what is also missing is here, we need to introduce a check here. Introduce a check if all bound names are correct. Basically not none. So here we can use these ones as well. I don't know the English word for them, so sorry guys, but yeah, I think you will get what I mean here. Yeah, that's fine, and now it gets more and more complex. Oh no, I was wrong. There is already a check. Delete this one. There's a check here. Here we check if the bounds are correct. So basically the new bound name should not be contained in the reference skeleton. That's what this line is doing here. And if it is wrong, we say this boolean here is true, then we move on. And if the reference skeleton also has not this parent bound, yeah, then it's also an issue, because then why is found parent here true? That's weird. That's a check if all parents are available. At least one should be available in the chain. So yeah, that's not an error here. Remove this error message. Remove error message. That's wrong. Yeah, as I said, it's still an experimental state, and I was working and tinkering with it a lot because we had a lot of issues to get it properly working. Yep, here we get the error message. So if no parent is found in the chains, the tooling would not know how to add those unweighted bounds, and we need to return false. Also, if the bound is already there, we set this boolean to true, which I said before, and then returns false. That's basically the easier to understand part. And then we move on. Let me quickly explain how this works basically. So yeah, it's a lot of code here, but you can simplify it a little bit. We get all skeletal meshes, and then we also have a counter here, which we need to know if we have added some skeletal meshes, because if you introduce unweighted bounds, you need to introduce them in the skeleton asset and also in the mesh, because if you don't do this, you will see those white dots or circles, and that means the LOD is not taking care of this bound, so basically it does not run late and so on. And for unweighted bounds, I try to edit all or adapt all LODs and then introduce those new bounds, and it seems to work for Miximo characters and metahumans as well. So the community is giving me good feedback for that. Yeah, thank you guys. So then we do the following. We need a for loop and iterate over all meshes, which is quite a lot of work. So if you have a metahuman, it might take you several minutes to process. Don't touch anything, just wait. It takes some time. There's no progress bar yet. And hopefully you will see no crashes, fingers crossed. So here we do a check. I would say yes, we have to do this, so remove this to do. Yes, a check should be performed So otherwise we might see issues and edit some skeletal meshes which are not connected to the skeleton, which might introduce some trouble for us. So yeah, this track should be here, and also this one, remove commented code. So here normally you have to take care about the rendering stuff and flush the render state, release the resources and wait, but somehow it did not work very well for metahumans. Maybe this is more if you want to introduce a skinned bone. But for unweighted bones, if you skip those checks, everything seems to be fine, and so far we don't see any crashes. If you use these methods here, you will see crashes or assertions, because yeah, it's very weird. And then we try to, what's this function doing here? It adds a new unweighted bone, right? Yes. So then we need to update the bone indices. That's super complex and super complicated. You need to iterate over all bones, get the mesh parent info. That's how it is stored in Unreal Engine. It's so complex. In so many classes is this information stored. And then we can ask this reference skeleton to get the raw bone number. And then we can iterate all over them and try to find the parent bone index. So if we have found it, we can skip or we can break those those for loop. And if we have not found basically it's index none, then we have an issue, because then we don't know where to introduce those bone, and we raise an error message here. So if this is successful, and this is a big if, we need to use this reference skeleton modifier stuff to edit the bone chains basically. Then we need to edit the LODs, that's this part here. And if this is done, we need to merge the new bones into the skeleton asset. If you don't do this well, it might get a lot of trouble. So here we need to do the following. The mesh got new bones, and it is necessary to merge those bones into the use skeleton asset as well. So this basically also triggers the re-indexing from the skeleton asset, because normally they are stored as integer values. And then yeah, we are not done yet. That's quite a huge function. And then we need to iterate over all bones and constrain them, the pose basically. That's what needs to be done here. And if this is successful, then we yeah, need to do a hack here, sadly. Through caching reasons, the use skeleton has internally a mapping table between skeleton meshes and the skeleton. As new bones were added, this table is not valid anymore. Force rebuilding of that table. That's very important, otherwise it will not work. And sadly, none of those methods is exposed to for plugin developers like us. Sadly, that's also why this smiley is here, this whining smiley. And we would need those functions here or those messages, but they are not exposed. Basically, they are not available if you create the shared library DDL basically. And yeah, we cannot do anything here. I tried to work around with this, and the solution I found is, yeah, that's why I said, but happily adding and removing virtual bones called internally use skeleton handle virtual bone changes, which should rebuild the mapping table. And then it can say, yoo-hoo, it works. For that, but we need to make sure that's what I need to rework here. Better unique name for the tempo come on, temporary virtual bone. So because then we can introduce a new virtual bone, which we can use the first one. The parent is this one, and also the parent is the source and the parent, the source and the target and the virtual bone name. And this is this name here. That's why I said it needs to be reworked. and then it triggers those reinitialization of the skeleton asset, and then we need to remove the virtual bones again to not destroy our skeleton asset. Then we need to say, yeah, post edit change, to notify every system that we did something to the skeleton mesh. And also we need to say the skeleton mesh has changed. That's why we call this modify method here. And then we increment the modified skeleton meshes. And if it is greater than 0, we also modify the skeleton asset. And then we are done and say, yes, we have a new unweighted bone, which we can then use this function here from Blueprint. But I also like to review this part a little bit more. So let me check. We were here. So what I said, we use this reference skeleton modifier. That's how the API is done. Give it a skeleton, ref skeleton, and the skeleton as well. Then you need to create a new mesh bone info, new mesh bone info, give it a proper name. I'm not sure what was the second argument. I think that's an f name and that's a string. And then you need also to provide a parent index. And then you can say reference skeleton modifier add. And if we go out of scope from this this stuff here, where is it? The reference skeleton modifier will be destroyed, and then it will update the stuff for us. That's a very weird API, but it works quite fine. Then, as I said, we need to move on with the LEDs. We need to fix we need to introduce those bones to the LEDs as well. So the level of detail, which is very important for optimization. And there we can do the following. We need to ask the skeleton mesh, get the imported model, and then use this LOD models. Then we get the LOD basically here, and we iterate all over them. And here we need to do the following as well. So we need to find the new bone index and the parent bone index. And this one should be not available. That's why index none. And the parent index, no. If one of them is none, we have an issue here because bone index not found in the mesh LODs. That's not correctly right because the bone index is not found in the skeleton asset. So that's a bit different. Rework this error message as the bone is not available in the skeleton asset. So that needs to be reworked to make it more clear what is going on here. Then basically something went wrong above here. Yeah, then we can add skeletal mesh bone, required bone, because there's active bones. These are skinned bones. That's an array. And there's the required bones. And the required bones are basically unweighted bones. And you need to introduce this new index here. Then there are two possibilities where you need to introduce those bones. One is that seems to be for newly imported skeletal meshes, and that's the one for old ones. And here we can say add skeletal mesh import data, and we will load the LOD imported data. That's the one which takes a lot of time. So you load this skeleton mesh into the memory, and then you can work with it. Sadly, we have to do this. There's no API around it, but it should be fine. And what I experience is with MetaHumans, the memory consumption goes up very quickly and very high. So I'm not sure if you will see some issues with running out of memory. So if you do, please let me know. If not, then it seems to be fine to do this, because normally I read that editor should take care about memory management. Hopefully it does it very well. For me, it is working because I have a lot of RAM. You might not have it. So for MetaHumans, that might be a pain. But anyways, then we say ref bones binary, and we need to increment the children's, because if we add a new bone and there is this, there might be a new children. That's why we need to increment this here. Then we say new root position, That's basically the transform and some values here. And then we need to introduce the bone. Yeah, it's quite complex, as I said. There we need to use the name 00. That's the number of children's. So when we introduce a new bone, it has obviously no children's. Then we say that we need to mention the parent index and the new position basically. And then we can say ref bones binary. That's where we can add those bones here. And then we can call the method save LOD imported data. So that's basically the LOD index, which we have stored here, and the skeleton mesh imported data, which we loaded into memory. And then we're almost done. Here also, there was also some init resources again, and it crashed the engine. Well, it crashed. There was an assertion then it did not work, so remove uncommented code. That's why it is here. Remove, not uncommented, remove commented code. Bam. So then, as I said, we need to merge all bones into the bone tree. Error message needs to be reworked as well. Then we constrain the bones, the unweighted bones, to the target locations like we have if you get a character from the marketplace. There we ask the skeleton mesh and the reference skeleton to get this constrain bone index. If it is none, then we have an error, of course, obviously, something went wrong. If it is greater than the number of the array, obviously, then also something went wrong. We need to continue. And if it is correct, then we can do the following. We use this class, which we have seen before, and give it the reference skeleton. Then it will take care about local and world transformations. And then we can ask this new class to get ref bone pose, so basically the world transform from this constraint bone. And we can then call the method set bone pose from this new bone with this world transform, which we get from here and in world space coordinates. And then again, we can get the new bone transform because we need the local transformations. That's why we don't have an argument here. Store this as well. So maybe we could use a const here. I really love to use const because it makes stuff so much more stable. Then you say as a developer, please don't touch this transformation anymore, and store it basically. There we need again to use the reference skeleton modifier. That's a class from Unreal Engine. We instantiate this class, give it a reference skeleton, enter the skeleton, and then we say update ref pose transform and give it the bone index and the new transformation. And then we constrain the bone also for the pose, which is super convenient. And I think this function is reviewed completely. What I would love to see is the following. That might be very helpful for us later. Can this feature be available as a own function that we can call from utilities, because that would us allow to constrain the reference pose as well if it is not. I have already worked with a character where it was not constrained, and you cannot edit this in Unreal Engine with the stock stuff. But now we know how to use the API, and we could introduce a new blueprint function. That would be very nice. So you might think we are now done with the review, but sadly we are not. Oh yeah, see, there's a to-do where I already was thinking about this feature as well. So basically we can just copy this one, not this one. Where is it? Here. So copy this one again. Yeah, as I said, it's quite some time passed since I wrote the code, and I don't remember any lines anymore completely, but that's fine. And also this one, I really hate to have local variables above the function. So this should be moved. Move this variable to the top of the CPP file. That's not done very well. So past Achim, what did you do? And yeah, I'm not sure if we should review this as well, because that's quite a long function as well, but it's very similar to the last one. So maybe come on, let's review this. I don't care about the length. Then we are done with the review. So same, check input arguments. If the bone name is, if the skeleton has no root bone, that's very important. And then we get again our skeletal meshes. Then we have a new counter as well here. We iterate over all skeletal meshes which are connected to this skeleton, and there's no check. Check if the skeletal mesh is really connected to the skeleton asset. Otherwise we might edit some meshes and don't edit the skeleton mesh, not the skeleton mesh, the skeleton asset, and we might have seen or might see some issues. But then again, it's the same. We use the reference skeleton modifier. We add the new bone, the root bone basically. This has an index none as a parent, so there's no parent because it's a root bone. And then we have to increase all the parent indices in this array with 1, because we introduced a new bone as the root of everything. That's why we need to change this here a little bit. Then we need to reset all bone transforms. So basically we say get retarget base both and yeah, delete the array basically. I don't know why this needs to be called, but that's how the engine does it. Calculate invariant reference matrices. I don't know why, but yeah. Then we need to use the LOD index as well. Again, we need to edit all LODs, so introduce those bound, and also increase the active bone indices by 1. So that's what we can do, because here we have a reference and then we can just increment it basically. And then if we have all incremented, then we can introduce the new root bone which has the index 0, very important, 0. And if this is done, then we need also to increase the required bone indices as well. And here again we need to introduce a new bone inside the root bone in this array as well. Then update bone references used by the skin weights. So we also need to adapt the skin weights indices, because this is also increased. And max total influences. I'm wondering a little bit if this array has really the size influence. That needs to be checked. So otherwise we write into memory which is not there and we might see a crash. So check if the array size, so basically the skin weight influence, has really the size of this one here. I found this macro or this define in the engine, but I'm not sure anymore if this is really the size of the array. If not, we might see some very weird issues. So increase source model inference bone indices to successfully register the root bone. So we also need to update this one as well. Adapt LOD sections. So if that's the same condition we have seen before, but we first review the else part because it's way easier to understand. Here we iterate over all sections and increment the bone index by 1. Yeah, if we introduce a new bone, we need to update all the data which is there, and that's what needs to be done. So for the new way of importing skeletal mesh, it's a bit more complex. We need also to load imported data. We need to count how many childs we have. That's basically this one. So basically, normally on the Miximo character, the pelvis bone or the hips bone, that's how it is called, is the root of the skeleton. And there we need to count how many childs we have, because later this num root childs needs to be introduced here for this skeletal mesh import data f bone structure. And here we need to mention the bone childs and also the position, which is the identity, of course. And with those values, that's also, I don't know why it is 100 here, maybe also 1 works. I did not try this because I was getting this information from the engine code. And then if we have this, we can introduce a new reference binary bone with basically, which is our root bone at index 0 in this array. And yeah, then we need to increment also the influences again for this LOD. If we have a morph target that's not correct, not yet supported, I don't know if you have a mesh with morph data. So if you see this warning here, I might be interested in the character if it works or not. And also the alternate influence, I don't know yet why or what those arrays do. Maybe you know, then you can extend the implementation. And if it is done almost, we can save the LOD imported data. And here again, if modified skeleton mesh is 0, basically the first time, because we want to delete the boundary or recreate it. That's what needs to be done at the first time. I tried this as well with the mannequin or with other characters, but it did not work very well, because then I had a lot of warnings and errors in the engine. So it only works if you have a new or want to introduce a new root bone, then you can screw up the skeleton mesh asset or skeleton asset and recreate the bone tree. And if you have already done it, we only want to merge the bones from this skeleton mesh into the skeleton asset, and that's where we can use this function which we have seen before. And then sadly we have the same issue that internally bone table map is not updated. We use the trick here again with the f name. So I think we should make a function here. So introduce a new helper function that updates the internally stored bone table map in skeleton assets. So then we add the virtual bone with the name, and then we remove it again, called post edit change modified the skeleton mesh, increase or increment the counter. And if we have more skeleton meshes which are changed, we also need to modify the skeleton. And then we are done. Then you have virtual bones basically. And so the last thing, let me check what is going on here, why we have this change here. So we have to copy anim montage curves. Oh yeah, that was an issue. Sadly, I did not notice it in version 0.3 that the target montage needs also be modified. So if we copy the curves from one montage to another montage, we need to say or tell the editor, we changed this, and you can save it. Otherwise, you might lose the work. and you have to redo it again and might wonder why it's not working properly. So there was only this comment, but I've totally forgot to call this function here or method. So yeah, I would say we are done now with the review. It might get quite overwhelming for you guys. For me, it was also quite overwhelming because it was a lot of code and a lot of to figure it out. As you see, storing skeletal meshes in Unreal Engine is super complex. And it's a huge code base, a very huge code base to import the FBX and then store it into the Unreal Engine structures. So yeah, that's why the code is here way more complex, and I decided to not develop it on the fly because I don't know yet the proper way to do it, and I wanted to give you the tools as fast as I can. That's why I decided to do this way. I hope you can understand it. You can still read the code when it's merged to master. So I think it will do it in the next few days or maybe 1 or 2 weeks, and then it will be available for everyone. I really hope you enjoyed the session and you might have learned a lot how I do reviews. So maybe you will review me in the future, and I hope you will also have some good findings so that we can improve the systems. See you in the next session, in the next feature. I already have something in mind which we need to implement for the tools to make it more convenient to work with stuff. See you.